All right, now that Flash Decon has ran, it has generated these files shown here. The MS1FT and the feature file. These are feature maps that I'll explain a little bit later on. This is the TSV file that is generated, and then there are two other ones that are broken down based on MS level. So the MS1 files are all, of course, the uh, MS1 information, so all the precursor masses and everything that is seen at that level, and then all the fragmentation data is at MS2 or greater. So, and then this is all the information that has all those fragment ions corresponding back to the precursors. If you were to open up one of these files, just to kind of show you what they look like, the MS align file is looks like this. So it is a very long list of information where you have IDs, scan numbers, retention time, and then for here, this is all MS1 information. So uh, yeah, so this is all just a long text file, and then the corresponding TSV file is going to be here. And when it opens up, okay. So this file has quite a bit more information, but it has inherently the same components as the MS Align. It has scan IDs, precursor masses, charges, and things of all that sort that you can sort through. And even though this file, the TSV file, is quite a bit larger than the MS Align, like I said, my program runs much faster with tab separated file because it's already in a structure that plays nice with making data frames. Okay, so onward to using pyMS-Vis. So, all right. So as you run this, you can run it through Python, which is preferred. Make sure that you have packages installed. Um, you'll need Boca. You will need matplotlib. You will need NumPy, pandas. All this is explained in the manuscript and also talked about a little bit more in the supplemental. So yeah, so that when you get it running, it should give you this screen. It looks very straightforward. If you so the first thing you want to do is of course add your files. So in this case, I'm going to add. Let's see here. All right. I'm going to add, let's see, I'll do the same analysis on both MS Align and TSV so you can kind of see the difference here. So just loading one file in, there we go. Here, just to kind of go through the operation, I'm going to keep it simple. I'm not going to name it anything. I'm interested in, say, the feature map. Why not? First thing you want to do is process the file. And then there are going to be a couple different options here. So when you first run it, I would recommend running it in static because that lets you kind of get the lay of the land and see if you have any of these masses you're interested in your data set, where they elute, and then you can go in and fine tune it. The program will automatically find the entire LCMS run, start time, scan time, same thing with the retention time. Here, these masses are automatically loaded. In this case, this is for histone H2A. However, of course, you can add anything you want. You can separate them by space or by commas. It doesn't really matter. In this case, however, I'm searching for about, what is that, like 11 or 12 masses. Mass error tolerance. So this will search any mass for plus or minus 1 Dalton, for instance. So if I see something that's 13487 or 13489, it's going to bin it as a 13488 mass. So you can change this by either Daltons or part per million Arabs, so part per million differences. So here, that could be that. Mass calibration. So let's say you know that after you did your acquisition, your data, the instrument was off 15 ppm. You can go and then adjust all the masses based on that by entering in some mass calibration. Here, deconvolution software is known to sometimes miss the monoisotopic peak, which will mean that your masses are off by a Dalton or an interval of 1.00235. So you can include that in your search if you'd like, and I'll kind of compare and contrast that a little bit later on. But here, entering these pretty straightforward parameters, you can quickly see if you have any of these masses in your data set. If you click process file, it will give you a loading screen that if it's one file, it goes fast, usually. So when it's done, you can click calculate average, blah, 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 show QC graphs. And then what you see here, oh great, is nothing. All right, let's see. If you see nothing, go back. So search parameters. So I'll just do 1 Dalton instead of 20 ppm difference. Again, so these aren't, the reason why I probably saw nothing, which is a good control, is that these are just integer values. If you were to put in your masses, you want to put in the monoisotopic mass as precise as possible. So let's say this mass would be, say, that many Daltons. So it probably didn't find anything because the actual monoisotopic mass was quite a bit different than what I searched for. But this is just an example. So if we just change this from 20 ppm to 1 Dalton and click search, okay, see what that looks like. Aha. Okay, so more in line with what I was expecting to see. Oops. There we go. There we go. All right. So let's see if we can do a little zoom out here. Okay, so what are you looking at? So here is a histogram of all the masses that were found, and it is tabulating the average abundance of those masses, where the intensities are all summed up to equal to 100%, and then so this is all the relative amounts of those masses that were found. If you have more data, this will be more complex and will show error bars and standard deviations, but that will come a little bit later. If you want to look at what the data look like in the coming off the column, you can zoom in to this bottom graph, and what you'll see in pretty colors is all the masses that you searched for are now represented as histograms showing elution profiles of those masses. So if you were to zoom in a little bit more, you can get a finer idea of what's going on. You can click these masses and turn them off so you can kind of get a better view, like, oh cool, look at these higher masses of H2A are eluting over there. Oh, these masses are eluting over here, quite a bit of a difference. Interesting, whatever. So this will tell you a little bit more information about how your ions or proteins or peptides are acting as they come off the column. If I reset this, you'll notice that there probably is some other unrelated proteins over here. that just happened to meet the search criteria. So if we were to quantify this, we would not want to add this information to our quantitation information because these are eluting way differently, probably unrelated, and they're adding values that are summed up and represented here. So you'll want to go back and change the search criteria, which I'll explain in 10 seconds or so. If you decided to load a feature map, this is what it will appear and look like. So if you were to zoom in, let's see here. Sure, why not? If you were to zoom in, you can get an idea of some of the mass intensities as they elute on the through the LC, and then different masses and intensities. And so you can use this information to also kind of confirm this data. So in this case, if I wanted to go back and take a look here, so 8,000 to 10,000, 8,000 to 10,000. Okay, cool. All right, and so if I were to put some money on it, I would guess this, and this would maybe be these peaks right here, most intense, alluding about that in those regions. Okay, so if I wanted to go back and change this so that I exclude this data from my quantitation, we can go back to the program without restarting it, click search parameters, and now you can go to dynamic. Okay, so here again it'll default the same range, mass range. Here, however, we can input retention times. So if I want to only include things between 8,400 and say 9,600 seconds, 8,400, 9,600. Let's keep this all the same. Process the file. Okay, and now it just has the data that excludes that. And because those were very minor peaks, you're not going to see a huge change in these profiles because the contributions of those peaks were very minimal. But in cases where they're not, you might have a radically different quantitation profile, which is obviously an issue if you're adding in masses that are erroneous, that are something else. Okay, so that is the basic gist of the program. I'm going to do another walkthrough where we're adding more data to our analysis.